All right, we're recording. So what we're going to do is if you want to put a title on here, I have the 5 figures or the 6 figures that we're going to be dealing with. We could call this properties of quadrilaterals. Now, there's going to be certain things that you have to be able to do. So your process is going to look like this. And again, I apologize. My handwriting will get better as the year goes on and my hand heals. So this is as good as it gets for now. 1, you're going to have to be able to graph. And this is what we're going to go through. We're going to graph the figure. This is why I gave you graph paper. Every chance that I get, I'm going to go and print out more graph paper and put it back there. So if you need some, you can grab some. Now, it only goes -10 to +10, but if you can see here, like this one goes to 20. Sometimes you'll have to change the scale, and I'll show you how you do that. Second thing, you're going to have to name the sides. And that's going to come from the picture. We have to see what the picture is. But it also comes from the name. Like, for example, find here is you can go through and say FI is going to be the first side, IN is going to be the next side, ND is going to be the next one, and then DF is going to be the 4th side. The names are written in order. And when you connect the dots in the order of the name. If it was A, B, C, D, E, you'd go from A to B, B to C, D, or C to D, to E, to F, back to A. So the name is important for any figure that you deal with because everything is done in order. So you're going to go, for hide, H to I is one side, I to D is another side, D to E, and then E to H, which closes the figure. And now there's one that goes to 11, so we don't have to change the scale. We just got to do an estimate. 2 or 3 is calculate the lengths of the 4 sides. So this is going to be a distance formula. So we're going to work on the distance formula with that. And then after every time that you do this, look for patterns. / relationships. Made it. All right. That's what we're going to do. We're going to see if there's anything special that happens once we find the sides. And we need a picture of it. We need a kind of an accurate picture of it so we can label the sides. So we're going to use our distance formula in that case. And if you want to, you can write it as D is equal to... I had you do this. You don't really have to. I'm just being complete here. x2 minus x1 squared plus y2 minus y1 quantity squared. So that's what you need to do there. Not necessarily. Now, for sure. Find the slopes of the 4 sides. So we'll use m is equal to I didn't need parentheses, but x2 minus x1, y2 minus y1. I just put it, like you said, you don't need parentheses. It's just that. Now, if you look, the x, oh, that's totally wrong. It's y's up there, and x is down there. It's still early in the morning. It's Monday. What do you expect? Now, x2 minus x1 is already calculated from the distance formula. We could take that number and just put it in the denominator. And y2 minus y1 is already calculated from the distance formula. You could put it in the numerator. So that finding out the difference of the coordinates is going to work out for finding out slope as well. So once we get that information, we're good to go. Yes, sir. That's midpoint. This one's slope. Now, the fifth thing you're going to have to do name the two diagonals of the figure. Now, you might not know what the diagonals are. That is perfectly fine. And you might not know what a diagonal is yet. You will. The diagonals are just the lines that you can draw inside that connect two of the points on the inside. And then instead of a period, we can put a semicolon and then find the lengths. So if there's lengths, we need to find them. Well, there will be lengths, so we need to calculate distance formula for that. And then step 6. Calculate the midpoints of the diagonals. And that's going to be using the formula where the midpoint is going to be a coordinate. It's going to be a point, x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. So you can think of this as almost like an algebraic lab, where you're going to get these figures and you're going to find out, just like you would if you had a mysterious substance, we want to find out things like density, we want to find out things like boiling point, melting point, stuff like that if you're doing a lab in chemistry. Well, doing a lab in math is finding out lengths, finding out everything you could possibly find out about it. The problem is, we're not going to find out anything about the angles from this, and that's okay. We could, but you don't have the required knowledge to do that yet. So don't worry about it. Not a big deal. We'll work with that later. And part 7, this stuff might look like a lot, but it's not a lot. It really isn't a lot. Part 7 is summarize your findings. So for these 6 shapes, we're going to go through this 7-step process for each shape. This is why it's not all going to get done today. Guarantee it's not all going to get done today. I'm going to go through and I'm going to model the quadrilateral hide for you. And I'm going to go through and name the sides and do all this so we all have a starting point. And then what you can do is This will be up on the web page. You can go and take a look at it. If you're working at home and you don't know what you're doing, that's fine. You can go and check it out, or get it done however you need to get it done. Any questions about the 7 steps that you have to take? And honestly, it's just go in order. Do this, then do this, then do this, then do this, this, and then you summarize everything. Helpful hints. Try to keep things organized. I've seen a lot of work that comes over my desk when I grade things, and it is just absolute carnage trying to read what's going on there. What you want to do is keep things organized as best as possible. You can keep that. So try to keep things organized. That's the biggest thing. When we're doing a lot of stuff like this, keep it organized. Use graphic organizers / tables. So we might want to put all our stuff into a table, and I'll show you a method for doing that as well. All right, any questions? Oh, that's going to be great on the video, me slurping out of a coffee cup. Don't care, sorry. All right, we're good? Good to go? All right, we're going to attack hide first. So you start with number 1. For some reason, I see a lot of people start with 3. I don't get that. Let's go after number 1. And we're going to follow this step by step. Now, I'm going to jump out of the workbook here. And I'm going to jump onto the graphing, or the graphs. And I do have this, which is the actual... the packet that I would have printed out for everybody. I'll put it online if you want to actually download it yourself. However, like I said, it's 6 pages long. There's 90 students, 6 pages times 90. That's 540 pages. It's a lot to print. So I didn't. And we can do it all in the book just as easily. Okay. So, what I'm going to do is I'm going to go to this next page right here, and I'm just going to put quadrilateral hide. And just so I have an extra page, and you might want to do 1 page per problem, or you can do half a page for one, do 2 of them on one, however you want to do it. But what I would like you to do first is take out the graph, and we're going to start with quadrilateral hide. And for this, whenever you're making a graph and you know that the sides are going to be straight, you're going to use a straight edge. So you're going to draw things straight. You can use your ID as a straight edge. You can do whatever you need to do. Now, a couple things we can, like for example, H is at 214. What we can do is we can say the scale is 2 times 2x. So what would 2 actually be? 2 would be 4, 4 would be 8, etc., etc. Now, I tried to get one that was blank, and I'm going to try in the future to have that. But if you say that the scale is 2 times, this is actually a 4, that's an 8, that's a 12, that's a 16, and that's a 20. And that can be how we kind of go through everything from there. Now, I would recommend using a different color other than black, just so it stands out a little bit. But if you don't have another color, no big deal. I'm going to use red, because I have multiple colors of pens. So H is at 214. 2 will be here, because we go by 2s. So that's 4, 8, 12. My brain is locked up. 16 and 20. So we go 214. So we 2 and then 14. There's 12. There's the first one. There's H. So H is at 214. I is at 711. So 4, 5, 6, 7. 7's halfway between the 6 and the 8, so it's right there. And then we go up to 11, so we're going to be kind of right in the middle of that box. There's I. And then we're going to get D, which is at 11, 1. So there's 11, and there's 1. So there's D. And E is at 6, 4. There's 6. There's 4. And there's E. E is at 6, 4. And so that's a picture of Hyde. It's a little bit small, but life will continue. So is everybody okay with that? Just because it says the scales are at a certain distance, if you change the scale if you have to, and there's a bunch of them that you have to, you don't have to ever change it more than 2 times what it is. So this is actually a pretty good example of doing that. Like I said, I'll have a blank one soon enough. This is the best I could do to get that. Now, does this look like anything that you would want to put a name on it? Take a guess. Okay. It kind of looks like a parallelogram, right? And I'll put a question mark and say, well, it might be a parallelogram. Let's find out. That's the thing, is it looks like a parallelogram. Let's find out. So, we drew the picture, okay? Can I move over to doing the math now? This goes a lot faster when you're doing it by yourself, trust me. It does. So, what I'm going to do is I'm going to work in here, and you guys are going to work on your notebook, in your notebook. So you're going to kind of cover, we have our 4 sides. What are the 4 sides? What's the first side? H to I. So we'll call it HI. The next side would be ID. The next side would be DE. And then the next side would be HE or EH, however you want to do it. Doesn't really matter. And so we have to find lengths. So how do we find lengths? use a distance formula, correct? All right, so for HI, I probably would have wanted to spread it out a little bit more. But for HI, I'm going to use these 2 points up here, 214 and 711. What do I have to do for the distance formula? All right, so that's my distance formula. But I'm going to do things a little bit different because I want to be able to use these values in different ways. I'm going to take and just draw an XY chart and put the 2 points in there. 214 and 711. Now, what did I have to do with the x's in order to use it in the distance formula? Add or subtract? Subtract. So what I'm going to do, I put parentheses around that one. I have 2 minus 7, which is negative 5. 14 minus 11 is just a 3. So now I'm kind of running into a little bit of space here. The distance formula is going to be equal to negative 5 squared plus, or the square root of negative 5 plus squared plus 3 squared. So what's negative 5 times negative 5? 25. Yep. Plus 3 squared, which is 9. So my distance, which I'll say is HI, is going to be the square root of 36, which is equal, what's the square root of 36? 6. So I found HI. Yeah, but you have to show all the work. Okay. Now for ID, I'm going to do the same thing. I'm going to come up with my chart, my XY chart. And for ID, it's 711 minus the point 11.1. 7 minus 11 is negative 4. 11 minus 1 is 10. So ID is equal to the square root of negative 4 squared plus 10 squared. Well, what's negative 4 squared? What's 4 times 4? 16. So I got square root of 16 plus the square root of 10, which is 100. So ID is equal to the square root of 116, and then leave it. Because we don't need to know the exact, or this is the exact value, so it's good enough for now. No, you don't have to do it as a decimal. So I got ID. Now I'll draw a little line there, and I'm going to work on DE, do my XY. D is 11.1, and I'm going to subtract off 6.4. What's 11 minus 6? 5. 1 minus 4 is negative 3. So DE is going to be equal to the square root of 5 squared plus negative 3 squared. What's 5 squared? 25. What's negative 3 squared? Plus 9. Now, you're never going to get a negative answer when you square something. So if you get a negative answer, go back and kind of look at it again. Uh-oh, what's the problem here? Yeah, What's 25 plus 9? 34. Oops. So HI is actually equal to the square root of 34. What is DE equal to? Square root of 34. And now we can do the last one, which is HE. My chart, E is 6.4, H is 2.14, subtract. 6 minus 2 is 4. 4 minus 14 is negative 10. Now another thing that you can do is you could just take this right here and square them. What's 4 squared? 16. What's 10 squared? 100. So the distance formula, and we're not going to need that much space here, the distance formula is going to be equal to the square root of 16 plus 100. So you can actually do that all here before you put it in the square root. And that equals 116, isn't it? All right, so D is equal to the square root of 116. Now, if you want to go back into the picture from this, and HI was the square root of 34, ID was the square root of 116, DE was the square root of what? 34, and D was the square root of 116. What do you notice already? What can I say about these two sides? They're equal to each other. So those two sides are equal to each other. These two sides are equal to each other. So when we get to our summarization, that's what we're going to summarize from this step. Now, what these are called are opposite sides. HI and ED are opposite sides. Does that make sense? That they're on opposite sides of the shape? These are opposite sides. And they're equal to each other. So we found that opposite sides are equal. All right, now find the slopes. Now the cool thing is, we've already done all the work. So the slope of HI is going to be equal to y2 minus y1 over x2 minus x1. Well, didn't we already do y2 minus y1 up here? Yeah, so what do we get for y2 minus y1? 3. So I could put the 3 right there. And what did I get for negative 5? So I can put the negative 5 right here. So I have my slope. And if you want to, you can say this is going to be equal to negative 3/5, because we don't like negative signs in the bottom. That's good. Not a big deal. Just as long as we know the whole thing is negative. Now, what's the slope of ID? ID, we're going to take the change in y, which is 10, over negative 4. If you want to simplify it, you can. Put the negative out front. Which would, if you simplified this, what would we get? Well, 2 would go into both of them. 2 goes into 10 5 times. Into 4 2 times. Now I want the slope of DE. DE, I worked... Where did DE? Okay, DE is over here. What's my change in y? Negative 3. Change in x is 5. All right. And the slope of HE. negative 10 over 4. If we reduce that down, didn't we reduce that same thing down over here? Negative 5 halves. So now what do you see? Remember, the shape kind of looked like this. Well, that doesn't work too good. Now, if we're looking for parallel lines, we're looking for HI and ED. What are the slopes of HI and DE? I get negative 3/5 there. I get negative 3/5 there. What does it mean when two slopes are equal? Well, they're parallel lines, aren't they? And we'll put that in our summary. Are there two other slopes that are equal? Slope of ID was equal to the slope of HE. So that's what you want to look for. That didn't sound good. That's my chair. Don't worry. Now, diagonals. If we looked at this shape, and let me zoom in a little bit here, and we're dealing with diagonals, what are the diagonals? Well, let me show you. The diagonals are going to take one point and connect it to the opposite side. So HD is a diagonal. What do you think the other diagonal is? IE. I-E-I-E-I-O. E-I-E-I-O. There it is. So now you have two diagonals. HD and IE. And when we get to special shapes, the diagonals are really, really important. Because we're going to find out special things about those. So, if we jump back to our next question, name the two diagonals, HD and IE. And we need to find lengths and slopes. So, for HD, make your XY. H is 214. D is 11, 1. Subtract. What's 2 minus 11? 2 minus 11 is a negative 9. 14 minus 1 is 13. So HD is a square root of negative 9 squared plus 13 squared. It's negative 9 squared. 81 plus 13 squared is 169. Add them up. 1 plus 9 is 0. Carry the 1. 8 plus 7 is 5. Carry the 1. So we got 250. So the length is 250. What's the slope? What's the change in y? Change in y is 13 over negative 9. Those are the points. This is h. That's the coordinates for h, and that's the coordinates for d. So h is 214, and d is 11.1. I subtracted them just like I did to find the distance between h and d for the diagonal. Yes. Now for IE, I has the coordinates 7, 11, and I'm going to subtract off E, which is 6, 4. 7 minus 6 is 1. 11 minus 4 is 7. All right, so the distance for IE is going to be 1 squared plus 7 squared. 1 times 1 is, plus 7 times 7 is, so that's equal to the square root of 50. And the slope of IE, 7 over 1. Change in y, which is right here, divided by change in x, which is 1. And now we got to find the coordinates of the midpoints. So I need to take for HD, take the same values for x and y, 2, 11, 14, 1. Now I'm going to add them. Because midpoint, remember, is you add up the x's and the y's and you divide by 2. So there's 13, there's 15. So I'm going to get 13 halves, 15 halves. That makes your midpoint a whole lot easier to find. And now I need IE. I just take the picture from up here, 7, 11, 6, 4, add them up. 7 plus 6 is 13. 11 plus 4 is 15. So the midpoint is going to be 13 divided by 2, 15 divided by 2. All right, now this is what you want to do for all 6, but I'm not going to ask you to do that tonight. You can if you want to, but we're running out of time, and I don't think we're going to have enough time to actually... This last part is to summarize. And I want to show you how to summarize this stuff before we get going with everything else. So if you want to do the math, go ahead and do the math. If not, that's great. Tomorrow what I'm going to do is I'm going to show you how to do the math for What's the next one? Play. So for quadrilateral play, I'm going to show you how to do this in the TI Inspire. To whereas you don't actually have to do... We're not done yet. I'm still talking. I'm going to show you how to use the TI Inspire, and you'll be able to create the polygon, and you'll be able to do all this without doing any calculation whatsoever. It's easier that way.